nature and engineering can intersect in the most fascinating ways? Indeed, we've reached an age where technology doesn't merely mimic nature but learns from it, evolves with it. This is the realm of bio-inspired engineering, a field that's revolutionizing our world by taking cues from nature's own solutions. From the microscopic patterns on a butterfly's wing to the complex social structures of a bee colony, nature has been perfecting its designs for millions of years. And now, we're using those same principles to drive innovation and solve complex human problems. In the next few minutes, we'll delve into 10 remarkable examples of how bio-inspired engineering is changing the way we live and work. From adhesive technology inspired by geckos, to energy-efficient buildings modeled after termite mounds, each story is a testament to the power of nature and the human mind working in harmony. Get ready to marvel at the ingenuity of nature and the human mind as we count down from 10 to 1. At number 10, we have the gecko, an inspiration for cutting-edge adhesive technology. This small, nimble reptile has a fascinating ability to scale walls and ceilings with ease. But what's the secret to this gravity-defying feat? It's all in the gecko's feet. Each foot is covered in millions of tiny hairs, creating a vast surface area that exploits the weak forces of attraction between molecules to stick to almost any surface. Engineers have taken cues from this biological marvel to develop advanced adhesives. Imagine a tape that sticks securely, yet can be removed without a trace, reused endlessly, and even holds up underwater. That's the promise of gecko-inspired adhesives. These innovative products are changing the game in industries from construction to healthcare, making our lives easier and more efficient. So next time you use a sticky tape, remember the humble gecko. Nature's little climber is behind some of the most exciting developments in adhesive technology. At number 9, we have the kingfisher, a model for high-speed trains. The kingfisher, an unassuming bird with a long pointed beak, has proven to be a remarkable source of inspiration for engineers. When a kingfisher dives into water to catch its prey, it barely makes a splash. This is due to the shape of its beak, which minimizes the resistance it encounters when piercing the water surface. In the late 20th century, engineers in Japan took note of this natural design to solve a significant problem they were facing with their bullet trains. As the trains exited tunnels at high speeds, they created loud booms that disrupted residential areas. By mimicking the shape of the kingfisher's beak, they redesigned the front of the trains. This new design not only reduced the noise but also increased the train's speed and reduced its energy consumption. Who knew a bird could teach us about speed and silence? Coming in at number 8 is the lotus leaf, inspiring self-cleaning surfaces. Now you might be wondering, how can a leaf inspire a cleaning revolution? The secret lies in the lotus leaf's unique surface. Tiny bumps on the leaf create pockets of air that water droplets can roll over, picking up dirt along the way. This process, known as the lotus effect, has inspired the development of self-cleaning materials. Imagine a world where your windows never get dirty, your car doesn't need a wash, and your clothes resist stains. Thanks to the lotus leaf, this is no longer just a dream. Scientists and engineers are creating paints, coatings, and fabrics that mimic the lotus leaf's self-cleaning properties, making our lives a little bit easier and a lot cleaner. So, the next time you see a lotus leaf, remember its ingenious design. A little dirt never bothered the lotus, and now it doesn't have to bother us either. At number 7, we have the termite, a mentor for energy-efficient architecture. You might be thinking, termites? Those pesky little wood eaters? Yes, indeed. But these small creatures are masters of climate control. Their homes, known as termite mounds, are marvels of natural engineering. These mounds, some reaching heights of up to 17 feet, are equipped with a complex system of tunnels and vents. This design allows for efficient airflow and maintains a steady temperature within the mound, regardless of the harsh conditions outside. Intriguingly, modern architects and engineers have taken a page from the termite's book. Buildings inspired by termite mounds use similar principles to regulate temperature, minimizing the need for artificial heating or cooling. This has led to the creation of more sustainable, energy-efficient buildings that not only save money but also reduce carbon footprints. From pests to professors of energy efficiency, termites have come a long way. Swimming into number 6 is the shark, a guide for fast swimwear. Sharks are known for their speed and agility in water, but have you ever wondered what makes them such efficient swimmers? The secret lies in their skin. The texture of shark skin is unique. It's covered in tiny, tooth-like structures called denticles. These denticles reduce drag and increase speed, allowing sharks to glide smoothly through the water. Taking a page from nature's book, Engineers have mimicked this design to create competitive swimwear. These shark-inspired swimsuits have a textured surface that emulates the shark's denticles, reducing drag for the swimmer. The result? Faster, more efficient swimming. This is another fascinating instance of how observing and learning from nature can lead to innovative solutions in our everyday lives. So the next time you're watching a swimming competition, don't just cheer for the athletes. Remember to give a nod to the shark whose design has significantly influenced the sport. Next time you watch a swimming competition, remember the shark. At number 5, we have the humpback whale, an inspiration for efficient wind turbines. You might be wondering how a creature of the sea could influence a technology meant for the sky. It's all in the flippers. The humpback whale's flippers are not smooth, they have large, bumpy tubercles. These bumps disrupt the water flow, creating swirling vortices that provide lift. Now, how does this relate to wind turbines? Engineers have found that mimicking the tubercle design on wind turbine blades actually increases their efficiency. The bumps, just like on the whale's flipper, disrupt the airflow, creating lift and reducing drag. This means more wind can be captured and converted into energy, even at low wind speeds. It's a classic example of bio-inspired engineering. By studying the design of a humpback whale's flipper, we've improved a technology that plays a crucial role in sustainable energy production. Whales aren't just for watching, they're for learning too. Quietly swooping into number 4 is the owl, a model for silent aircraft. The owl's ability to glide through the night with barely a whisper has long captivated scientists and engineers alike. But what exactly makes these feathered creatures so stealthy? Well, it all comes down to their unique wing design. Owls possess a soft, velvet-like texture on their wing surfaces which reduces air turbulence and the accompanying noise. Additionally, the serrated edges of their feathers cut through the air, further dampening sound. This fascinating combination of features has led to breakthroughs in the field of aeronautics. Engineers have started to apply these principles in the design of quieter aircraft, reducing noise pollution and making for a more peaceful journey for passengers. In the same way, the owl's silent flight has inspired advancements in military drone technology, leading to stealthier reconnaissance and surveillance operations. The owl shows us that silence is indeed golden. Crawling into number 3 is the spider, a source of inspiration for strong materials. The spider, often overlooked and sometimes feared, is an engineering marvel in its own right. The real magic lies within its silk. Pound for pound, spider silk is stronger than steel and tougher than Kevlar. Yet it maintains an incredible flexibility, able to stretch up to 40% of its length without breaking. Scientists and engineers have been studying this remarkable material, hoping to replicate its properties for human use. Through advanced genetic engineering and nanotechnology, they've made significant strides in creating materials that mimic the strength and flexibility of spider silk. These new materials have the potential for use in a multitude of applications, from constructing earthquake-resistant buildings to manufacturing bulletproof vests. The spider, small but mighty, has much to teach us about strength. So next time you encounter a spider web, take a moment to appreciate the engineering marvel that it truly is. Fluttering into number 2 is the butterfly, inspiring advanced display technology. The enchanting colors of a butterfly's wings are not just for show, they're a marvel of natural design, with microscopic structures that interact with light to create shimmering, iridescent hues. Engineers have been intrigued by this phenomenon, and have taken cues from these tiny creatures to develop innovative display technologies. The color-changing ability of butterfly wings has led to the creation of screens that can alter their color with remarkable precision. These butterfly displays, as they are often called, utilize nanostructures similar to those found on butterfly wings. This bio-inspired technology has the potential to revolutionize the way we view and interact with screens, from smartphones and tablets to televisions and computer monitors. Imagine a world where your screen is as vibrant and dynamic as a butterfly's wing, changing hues with the light or even with your mood. The butterfly's wings are not just beautiful, they're instructive. Buzzing into the number 1 spot is the bee, a model for efficient networking. These tiny creatures have a complex society, utilizing a variety of communication methods to work together seamlessly. This is not just idle buzzing around, it's a highly efficient network where each bee has a role to play and a message to share. The marvel of bee communication has inspired scientists and engineers to create more efficient networking systems. Just like a bee colony, these systems are designed to communicate vast amounts of information quickly and effectively, ensuring that every part of the network is in sync. From data centers to traffic management, the principles of bee communication are being applied to solve complex human problems. It's a testament to the fact that even the smallest creatures in nature can hold the key to big technological advancements. The bee, a tiny creature with big lessons for us in networking. And there you have it, our top 10 countdown of bio-inspired engineering. Quite a journey, isn't it? From the adhesive technology inspired by the gecko to the efficient networking techniques we've learned from bees. Each of these examples highlights the incredible potential that lies in studying and emulating nature. It's not just about appreciating the beauty of the natural world, but also about understanding and harnessing its wisdom for our benefit. The kingfisher's sleek beak guiding bullet train designs, the lotus leaf's unique structure inspiring self-cleaning surfaces, or the humpback whale's flippers refining wind turbine blades. These are all testaments to the power of bio-inspired engineering. Innovation isn't always about creating something entirely new. Often it's about looking at the world around us with a keen eye, learning from the best teacher, nature itself. Remember, nature isn't just beautiful, it's a treasure trove of ingenious solutions waiting to be discovered.